Ma'am, YouTube live and recording is being on, ma'am.
Ma'am, recording start பண்ணும்போது ஸ்டார்ட் பண்ணலாம் மேம். ரெக்கார்டிங் பத்தி பாஸ் பண்ணிடுங்க.
ரெக்கார்டிங் பாஸ் கொடுத்துடவா?
ஆமா, ஸ்டார்ட் பண்ணும்போது பண்ணிக்கலாம். யூடியூப் லைவ்ல இருக்கட்டும், ரெக்கார்ட் மட்டும் பாஸ் பண்ணிடுங்க.
ஓகே, ரெக்கார்டிங் பாஸ் பண்ணிட்டேன்.
ஓகே.
சாண்டி சார் மட்டும் வராரான்னு பாத்துக்கோங்க.
ஷூர் மேம் நான் பாத்துறேன். ஃபேபியோ அப்படிங்கற நேம் தான மேம்?
ஆமா, ஃபேபியோ நேம்ல தான் வந்தாங்க சார்.
ஓகே மேம், ஓகே. Ma'am, sir in the line, ma'am. I joined it.
Yes.
Yeah, I am again.
Yes, sir. Welcome, sir. So we'll wait for some more time, sir. Still the participants are joining, sir. So
Yes,
once they join, I'll give a small introduction about you, sir. Then you can start the session, sir.
Okay, thank you.
That time you can start sharing your screen, sir. I have now given you the permission to share the screen, sir. I have given you the co-host, sir. So after the introduction, you can start sharing your screen, sir.
Okay.
Yes, sir.
Okay.
Yes, sir. So your background is nice, sir.
You like it?
Yes, sir.
Oops. So, okay.
Yes, sir.
You are a small polytechnic there. Your institution is a small.
Yes, sir. We happen to be a Union Territory, sir. Pondicherry is a Union Territory, sir. And our college is one of the top institute in the Union Territory, sir. Yes, sir.
Ma'am, shall I admit all, ma'am?
Yes, sir. Sir, you can admit, sir. Sandy, sir, you can mute the participants on entry, sir.
Okay, ma'am.
Yes, sir.
त्याच्यासाठी बाय द वे.
Sandy sir, we can start the session. You can allow the participants to enter. A very good evening to one and all present here. It's my pleasure to welcome you all to the International Webinar Series Allied 2020, and we are on the day 4 session, and amongst us we have Professor Fabio Bonsigaro, CEO and founder of Heron Robots Italy. It's my pleasure to introduce Sir. Professor Fabio is a founder and CEO of Heron Robots, Advanced Robotic Solution. He has been visiting professor at the Robotics Institute of the Seoul Superior Saint Anne's in Pisa from 2014 to 2019. He has been professor in the Department of System Engineering and Automation of the University Carol's III of Madrid until 2014. In 2019, he was awarded the Santander Chair of the Excellence in Robotics at the same university. He has been working in the R&D department of several major Italian and American companies for more than 20 years. He has been a member of the Research Abroad of Directors of SPARC, the EU Robotics PP twice, and he is coordinated and he is a main teacher of the Shang AA Lecture Series 2013. He has pioneered and introduced the topic of reproducible research and benchmarking in robotics and AI. He is a reproducibility editor of the IEEE Robotics and Automation magazine. He is an author or co-author of almost 200 peer-reviewed publications. He is pioneering the topic of blockchain application in robotics and AI. He has organized or co-organized several workshops and symposia on the topic at the European Robotics Forum IEEE Roman, and since 2018, he has been in the organization of the symposium on blockchain for robotics and AI system MIT Media Lab as a program chair. He is a member of the Georgia PhD Award jury. He is a coordinator of the IEEE Robotics Topic Group of Experiment Replication, benchmarking the challenges and competition, and is a co-chair of the IEEE RASTC Performance and Benchmarking of Robotics and Autonomous Systems. He is a stakeholder leader and robotics task leader of the Cost Against G2 Net, studying the application of machine learning and deep learning to the study of gravitational waves, geophysics, and robotics. He is a distinguished lecturer for the IEEE Robotics and Automation Society. I once again welcome you, sir.
Thank you for the kind introduction. I am very happy and honored to having been invited to give this seminar. My purpose today will be to share a few informations and a few ideas about the many opportunities opened by robotics and a few issues that we should cope with if we want to fully exploit the potential of robotics. I will also, of course, one of these issues is one that you may have understood by the introduction, are the issues related to reproducibility and benchmarking of the proposed solutions. But there are many, maybe more opportunities than issues. And in this short presentation, I will try to give you a glimpse of what really can be done and how many really opportunities are opening right now. My talk will start with a very short introduction about the great challenges. One is the pandemic, but I'm sad to say probably it's not the biggest that we as a global community are facing right now. Then I will give you a kind of a very short history of robotics. And then I will give you some, I hope to give you an idea about what is happening now and what we as researchers, students, people interested in robotics and AI can actually do with the technology already available today. Then I will finish by discussing some issues that we still have. And if we have time, I would like to briefly discuss the societal impacts of what's going on. So global challenges. You know that, I don't know, I think that you probably know this movie, Inferno, taken by a novel by Dan Brown, where a crazy scientist spread a virus to reduce the growth of population. Actually, what we more or less know is that by 2050, we will have at least 10 billion people on this planet. And this is posing some serious stress on the resources. I mean, we hear every day to talk about worried talks about the climate change. So actually, right now, we know that if we don't have a change in the technological recipes that used to produce cars, fridges, everything that we use in everyday life, And as expected, most of the population, or a significant part of the population of this planet, will enjoy a kind of life similar to that of already industrialized, more industrialized countries. Someone say we would need 8 planets. Someone says 2, 3, but for sure we are going to stress. We don't have, if nothing change, we don't have enough resources. And what's also happening is that while countries like Japan, Europe, even China are suffering by an aging of a population, and unfortunately, those are the countries where you have more technological resources. We have actually other mainly Africa. They have a huge young population which is not particularly educated. So we are going to have a kind of asymmetric stress, because some countries will have problems, potential problems of shortage of workforce, and other countries, typically African countries, will have a huge problem because they will have a booming population with not a lot, not an educated population. So this is a clear issue that we are facing. We know also that this change in the climate is creating a lot of cascaded issues like the mass extinctions. And so it seems we really have a short note about the Paris Agreement on climate. So they are not arbitrary. You know, this limit of 2 degrees actually is what separates a situation which is going to get worse. So warmer summers, warmer winter, which maybe is not so bad, slightly higher sea level, from another equilibrium point in the climate system of this planet, which is plus 8 degrees and plus 10, 20 meters of sea level. Of course, it's a critical issue for humankind to stay below 2 degrees. So why I'm talking about this when I wanted to introduce robotics? I want to talk about this because if you think about what we should have done and we are not doing with respect to the climate crisis, which is the most compelling one, or what we should do where we have aging population, or what we should do to provide housing to these 2 billion people who will come in 20 years, 20, 30 years, but 2 billions is not, could be 3 billions. So we don't have, if we don't change our way of working, it's almost impossible to do what we should do, because we should build houses for billions of people. A lot of people still need improved infrastructure. In the meantime, while we still have to develop all the many areas of the planet, we should also be changing all the system from carbon-based power supply to renewable power supply. We should build new grids. We should redesign, we should change, for example, cars from gas car to electric car, and all in 20, 30 years. This requires a level of productivity that requires a level of automation that so far we don't have. So people worried by the possibility that robotics or AI destroy employment. The reason why I want to highlight what we have to do in the next 20, 30 years, this is particularly important for the students, no? The world that we are facing and you are facing. A little older people and you who are starting and you will start your professional life in a few years. It's really a challenging world. What now we will see in more detail during this talk, but the point is that 1 hour of work of today should be able to do, of a person should be able to do 10 times or even 100 times more that we can do now. How we can do that? We can do that by automation, by robotics and AI. So far from being a problem, actually, it's not the only component of recipes. So we need politics, we need societal innovation, we need a lot of effort. But the technological basis that can allow us and hopefully will allow us to cope with this challenge and in the end have a much better world is actually robotics and AI. So let's talk about a short presentation of what's happening in robotics. So the idea of robotics, as you may know, it's actually quite old. So it's the idea of having some kind of state machine, like a clock, which moves a physical system. We have very old examples. This one from Renaissance Spain is not even the older. And we have recent times, but conceptually, there is not a big difference from these old robots where a clock was the equivalent, was performing the role of a computer, and you had a physical arm playing the lute, or you had the monk bowing to pray. And then you go to modern androids. Also the idea, and this is about the societal impact, that you may have a machine which governs itself is actually very old. This is a European Greek from almost a couple of millennia ago, which already identified this problem, right? Because basically, you know that in ancient Greece, in the time of this philosopher, they had slavery, not de facto slavery, real slavery. And in one of his famous books on politics, he was kind of explaining why you need, he was justifying slavery. He was saying that since in a society, you need that someone think about the future, someone study science, someone think about how to organize the state, someone else has to do the daily course, no? Like cleaning the floors, agriculture. And so his idea was, that's why it was his argument, we need slaves. But what is interesting from modern readers is that he said, of course, if machines could govern themselves and do the jobs, we would not need slaves. So if you think about now we can have this kind of machines. So this is an example from the Enlightenment, so a couple of centuries ago. Again, if you look behind what today you do in a computing, so in a program that you write on a computer or a PLC, it was done by gears and pulley. But conceptually, it was the same thing. You have a state machine and a clock. is a typical example of a state machines, which at different states does different things. This writer by the Drozd brothers actually was able to could be programmed to write short phrases of 40 letters. So it's almost nothing today, but it's not it's something remarkable. This is same thing in Japan, same age. And this Karakuri Zui is probably the first modern handbook of robotics. Okay, it's almost a commonplace to say that what changed in the 60s of the past century was that thanks to microprocessors, it was possible to build really effective robots, because what you can do with a clock is what probably is exemplified by this writer automaton. So you can write phrases of 40 letters, which is not, it's not great, but it's nothing really useful. With a microprocessor, it was possible to do what we do today. So today, there is no car, no fridge, no washing machine, no smartphone built without using in some steps of the production process some robots like the ones that you see in the video. These robots are not robots with very limited sensing, which follow pre-programmed paths. So it's very similar, if you think about it, to those robots of the past centuries, but much more effective. In this, what we can call the first wave of robotics, which led to the fact that in industry, even when they move a plant to a low-income country to save on the wages, you will still have to use robots because they allow you to reach the prescribed level of quality, so of repeatability. So the holes in the structure of the car, in the body of a car, are all in the same place, and the dimensions are the right one. And when you put the doors in the right place. To do that, robots are much better than humans. And that's why you need, like writing a formal letter by hand instead of using Word, right? So it's a need. And this first wave of automation was based on three main areas of knowledge: mechanical engineering, computer sciences, but really program a state machine in a computer, and control engineering. So to control a motor to follow a prescribed path. Starting about 10 years ago, what's happening is that we had three major changes. That three major technology became good enough, so mature enough to be used every day. And these are the Internet of Things, the machine learning, and the artificial intelligence. I will give you more detail later, but this is something that in principle and in practice allow us to pass from a blind robot following a pre-programmed path to a robot which can interact with the environment. I will come back on this. And so one, these three things have allowed what is the current massive development of robots. So there are several examples, several studies, but all more or less converge to say on these numbers, right? For example, this study was a study making a forecast for 2020. I can tell you that we are above those numbers. And we are more close, year 2025. The expectation is that by 2025, it will be about 80 billions. This is what is called the Industry 4.0 or smart factories or fourth industrial revolution. And that is having a really a significant impact. Why? Because because the main technology are those that we were saying before: the Internet of Things, machine learning, and some AI. Where what is actually this is relevant because basically what they allow is to think to make the production more flexible. Because so basically the idea is that you get the costs of mass production, but you give a product that can be mass customized, tailored, a lot of, so you can have at the cost of mass production, you can have shirts made one by one, like from a tailor-made. And this is important because what happens in the markets of consumer goods, which means the things that you use all the days, from the smartphone to the washing machine is actually, or of clothes, is something which is changing, is turbulent in the fluid dynamic sense. So the mix of products and the quantity of each product that people want in the market changes in a very, very random and unexpected way. It's turbulent. And this, if you have production lines, it's which are flexible but not so much, is a big problem. The example is the car industry. Car industry, for those of you who look into the financial pages of the newspapers, have years where they earn a lot of money and years where they lose a lot of money. This is because there are years where everybody wants cars and years where people don't want cars or wants a different model. So one year they want the Spider, the other year they want the station wagon. And if you have a structure to build massively Spider cars, when people suddenly want station wagons, you are not able to sell, and you have an inventory which is worth close to zero. So this is a huge change in the things. Today, thanks to these technologies, it's possible to organize a factory like an artisan craft work. And also it's possible to, like in these scenarios from Piaggio is the producer of Vespa, is the Italian scooter that you see in this picture. Also, you can relieve workers from by exoskeletons, by repetitive jobs can be delegated to work. And you can also dismantle things. So why, let's go a little bit deeper into this. What really has changed? So Internet of Things. Now, the first thing is this one. So not many years ago, if you wanted to connect a computer to the internet, you needed a card which costed hundreds of dollars. So this means that you could only connect to the internet expensive things. Now, to connect with a phone or a speaker or your washing machine to the internet requires a small electronic component which costs 50 cents or even less. So this means that now everything can be put in a network. For example, a component that needs to be assembled can have a small interface telling me what I have to do with it. But, or a chair could tell you what's the weight of a person sitting on the chair. That could be nice for jokes, but could also tell me with a little bit more sensors if I am sitting in a proper way. Or even if I am, for example, you have seen those working in a factory, I could know if the way that they lift the weight is correct for their health. I could also see if they work or not. And this could raise some privacy issue. But the point is that I can connect almost everything, first thing. Second thing, machine learning and deep learning. You see every time that you use a voice assistant, you realize that now it is possible by a machine which is based typically on machine learning or deep learning to recognize some simple command. It's also possible to recognize a pattern, for example, in the vibration of a motor. It's possible to recognize a pattern, a connection between the quality of the car coming out from a line and some steps of a production line. And it's also possible, and this is the third bullet here, to recognize objects and to do some planning. Okay, and the limits now of the technologies are the limits that you know from voice assistants. So you can't do everything. You can't expect a great creativity for your intelligent assistant, but you can do many things. For example, if you have a basket with different objects and a camera and an arm, the arm can take the objects that you want from the basket. It seems very little, but this was not basically possible until a few years ago. If you want to be really optimistic, 10 years ago, but it's really something that is possible. If you look at the long term, it's something possible now, and that some industry is already doing. Some are not, like every time that there is an innovation. So some people arrive earlier and some arrive later. But if you think about these three things are what enable a lot of new applications. Then, to be honest, you know that a deep learning network is basically, you know, if you don't know, I tell you, it's a neural network with many, many layers and many, many nodes in input and maybe not so many in output. To me, it was a surprise that by adding, so neural networks were already popular a couple of decades ago, but they kind of worked, but they don't really work, not well enough. What to me was kind of surprising is that if you add many layers, suddenly they started to work with a very good accuracy. So not 78%, but 98, 99, or even more in some application. So it seems, and this is an example, that actually there are some serious mathematical reasons for that. So as you know, you in particular in India, you know very well, the industrial revolution actually started in the UK, and it started from the textile sector. So it is, so this, what we see in this picture is probably the very first factory in history. And it is it's a cotton mill in Derbyshire. And where they introduced the very little automation. So the spinning jelly, which was a machine for spinning cotton, and the mechanical weaver that connected to a steam engine actually guaranteed to the UK an economical leadership for about 1 century. So if the UK was able to dominate the world for about 1 century, it's because they were the very first adopter of of industrial model based on mechanization that we use nowadays almost everywhere. And despite that, what happens is that the textile industry was the first to enter in this industrial age, but now it's well behind other industry, so, because the final assembly of clothes is made almost manually by humans. This is one of the things which are going to change. So, okay, these are the robots. This is on the left, the black and white picture is the very first robot, which was deployed in a General Motors factory in 1965. And this is an assembly line of a car factory, more or less today. But again, like the principle is more or less the same. So those are blind robots. What is changing now is that if you have sensors on robots, cheap enough sensors, because it's not that here you could not, in the black and white picture times, you could not put sensors on the robot, but they were extremely expensive and they could use them for space exploration. And they were extremely expensive to connect. And also the bandwidth was really very low. I mean, not a long time before, having 26 kilobytes of bandwidth was considered good. Now we complain when we only have 5 megabytes. So it's completely, it's a different world. What you see here, it's pretty different from what you have seen in the previous picture, because in the previous pictures, I go back, you don't see any humans around the robot, because a robot is something which moves very fast, with a lot of inertia, and so it's very harmful and dangerous because it is blind. So it's following a trajectory. If you are in the trajectory, you are hit by the robot. What it's possible by the things that we have seen, the main 3 things that we were saying before, without, of course, we still use control theory, and we still use computer, and we still need to design the mechanics of these machines. But now robots can work together with humans, while before they had to stay well separated by fences from humans. And this is a big change, because even in the example below, you see that the robot is on the human. If you think about an exoskeleton, is a robot which is on you, which interact on you. And a lot of new, basically by these 3 changes, Internet of Things, so possibility to connect everything, machine learning, possibility to extract pattern. AI, possibility to recognize simple commands and to recognize objects in a picture, in the video, and to do some small plan, allow a lot of new stuff. So the next, so self-learning thermostat, no? So it doesn't require programming. It learns from the commands that you give it day over day. Reusable rockets, drones, all these things are made possible, but by this change in the available technologies. Agricultural technology. So if you have sensing, you can use a robot to sew or to destroy the weed, or another kind of robots, self-driving cars, or underwater autonomous robots. So, so this is a challenge for you, for the students, right? So you should look around your daily environment where you live, the things that you do, and think what I could do if I put a small chip to connect to the internet, and I can do some image recognition and some sense recognition. So you could, for example, now it's popular to check the temperature of people entering in a room. This can be can be done by an infrared camera and a small algorithm checking if you are so analyzing the picture, or for example, of your front, and calculate your body temperature. This is a typical application of vision and machine learning. If it is static on the floor, the infrared camera, it's not robotics. If it is on a robot which comes in front of you and look at your front with an infrared camera, that's robotics. I was giving you the example of a chair which check if you are sitting well. I mean, you have all those applications of domotics, like you enter in the room and you open the light up the lights, but it could be better, because if I have some face recognition, the level of light could change depending if I'm me that I prefer a lighter room, or if you that prefer a darker room, or maybe in some situation I prefer some different colors. I prefer to open the windows. So they are really, if you think about these three things and you think that they are cheap, you can think to an enormous number of new robots. And really, because when I say now, there are already factories. For example, Barilla, the pasta producer in Italy, is already using this technology at the level that you can. So they have mobile robots moving the packages in the factory, but many others are not. So it's a situation like really like the beginning of the Industrial Revolution. So who will implement the new technology well and faster will have an advantage. So I think this is a huge opportunity for, it's also a huge opportunity to improve our quality of life everywhere. But you may think I'm contradicting myself, because in the beginning, I was saying that depending on the calculation, if we want that everybody enjoy the lifestyle, not of the Americans who really use a lot of resources more, but the Europeans that are more parsimonious in the use of raw materials, we would need several planets. So, okay, I'm just saying that we can really invent a lot of new consumer products, improve consumerism for everybody. And even more, and then I say, what happens with resources? Well, a nice effect of this Industry 4.0 revolution, change in the technologies, is that if your robot have eyes and sensing and force sensing, so can touch if a screw is resisting without, so it unscrews screws without breaking them. So I can use it also to disassemble. And if I can disassemble old cars when they reach cars, or I use the example of cars because it's very common, but it's applied to all this stuff like washing machine, telephones, whatever. No, all big manufactured item, large scale manufactured items. What happened before was that on the one hand, I had factories creating a new car every few minutes. I think the world record is 1 minute, new car every minute. But let's think 5 minutes, 10 minutes. On the other hand, when this car gets obsolete and reach the end of its life, I need to disassemble. Until 10 years ago, disassembly was a few people working on the car and extracting all the different material. There was no competition because new car every 10 minutes, several hours of people working to disassemble the car. Now, if you think about it, if you have vision and force control in a robot can disassemble cars. So this is one of the main, I think, promise of the so-called Industry 4.0 or new, call it digital industry, is the possibility to make really possible the so-called circular economy. Change number one. And this actually prevent the risk that I was saying before, no? Because one of the problem that we are facing is not the fact that we cannot produce more. It's the problem that by producing, we are impacting severely the environment. It seems that we have a solution. This is something which is starting. Another thing, these technologies, so the possibility of having a robot with eyes and connected at a low cost, and allows, for example, to use a robot in agriculture or in fish farming, makes it possible to use drones. And this is also allows to manage agriculture in an highly mechanized way, but in a regenerative agriculture is the agriculture which try to use less fertilizer and less insecticide to avoid it, but above all to keep the soil usable in time. So you could call it sustainable agriculture. Actually, this requires a lot of data processing, of learning patterns and to react accordingly. So this is another thing that the technologies that have been developed in the industry can be used for this also in the architecture. And then there are things that are more close to robots, hydroponic farming, or even meat meat production by cells, but this is by bioreactors. So it's, and it's a point two. So industry can be completely changed to create tailor-made at the cost, individualized production at the cost of mass production. And this in a market where fashion is leading, it's extremely important to have a lead or to keep a lead if you have a lead. Second, agriculture can be radically improved by using, and a lot of new things are possible. So this is the challenge to the students. Think to these three components and apply to all the things, including furniture and buildings around you. Third thing is on construction industry, because it's a long story, the story of providing everybody with a decent house at an acceptable cost, which is now this is less compelling in Europe, because in Europe we have a declining population. But not many years ago, it was a terrible problem because everybody was moving to the cities, and so a lot of very bad houses were built simply because you had to be fast and you have to keep costs low. This is now in many areas of the planet. You think to Africa, 2 more billion people, it's a very serious problem. So prefabrication is something that people has been pushing again for decades, like sustainable production and like mass customization, but until recently was not possible. But now, if you think about personalized prefabricated construction and maybe partially robotized assembly in the field, is a way to massively improve the productivity of a construction industry. So industry can be revolutionized because it can be highly customized, can become sustainable. So we may solve the problem of resources by build the new car by using the material of the old car, and in the case of car, but of almost everything, the new car typically uses less material than the old car because the design is better. And this is, so actually we may even reduce our impact on the resources of a planet. And then construction. So industry, agriculture can be impacted by these three things. Some AI, some machine learning, and really for young people, this is the big challenge. So you can literally change the world. I think that the last time, I'm not exaggerating, the last time that there were so many opportunity to improve daily life, which means how you produce things, how you produce food, how you produce houses, how you eat or refresh houses, from the UK 18th centuries, end of 18th. So from the Industrial Revolution, we hadn't an environment where there is space where you can invent something new. And where the simple adoption of a new technology can improve many human activities. So this is really a great moment to be, in particular, an engineer. And the only thing that you need to understand is that you can put intelligence in objects and in machines, and not a lot of intelligence, but you can give eyes and capability to see patterns in the chain. Not very much, but enough to do what I've been discussing now. So are we in the best of a possible world? So there is nothing to do from the basic research standpoint, and on the other side, a lot of work in so-called innovation, so to change, so to invent new things, or to change the way you build old equipments or old machines. Well, no, we have still some problem. This is the DARPA challenge, the DARPA Robotics Challenge, which was held 5 years ago in the US. The DARPA is the defense research agency of the US military. And you can imagine what they have in mind, right? Because if robots are good for dangerous, dull, and dirty jobs, the military is one of those jobs, right? So they organized this challenge, as maybe many or some of you know already, where basically they challenged humanoids robots to do 3 things which should seem very, very trivial to us. One was to open a door. Another was to turn a valve, close or open a mechanical valve on a pipe. And another one was to sit in a car and put your hands on the steering wheel. What is interesting is that these machines, which are very complex, much more complex than a car, for example, and were most of the times not able to perform those simple tasks. This is, for example, is a robot also just reaching the doors that you should open was a difficult task, or climbing a stair. So there are a number of basic tasks. What happened is that those robots, whose average cost is $1 or $2 million, weren't able to perform, were able to do these tasks, those tasks, but say 5% of the times first. But what is even more striking, I think, is the fact that since they are very serious, they organized a background study. So Oli Yanko, who is a professor from the University of Maryland, was doing a kind of sociological study of the teams participating in the competition. And what is interesting is that the average time that they were able to, so the average number of people teleoperating those robots, because they are teleoperated, was 10 something, and the minimum was 9. So it seems we have, so there are limits to what we can do. And so the next frontiers, and this is a project where I am involved, actually, which is almost finishing this year, because it's a preparatory proof of concept project, is that probably if you want to go forward, I don't have time today to go into the time this, you need a totally new approach to robotics, which in very, very short is based on a deep understanding of biological systems, because it's clear that our most sophisticated robots are not even at the level of a spider. and because the spider is designed, so to speak, in a totally different way, because we have top-down control. Biology has emergent order from many loosely connected parts. So it's different. So for example, human cognition, animal cognition is clearly different, much more robust and flexible than current AI methods. So many things, many people think that we need a third wave, but the third wave has still to come. But just to finish this on this, now I'm afraid I should come to an end in not a very long time. Because if you think this is, I told you that it's not 60,000 billions. We now expect 80 billions of dollars of total turnout of robotics. If you may add AI, it's more. But if you compare to the global gross product, which is more, it was, so it grows, this year it won't grow, but it's already more than 80 trillions. You see that all robotics is 1,000 as order of magnitude of the economy. Well, in principle, if you want to have a digitalized, intelligent economical system, should be much more. So the idea is that these fundamental bottlenecks, so the fact that you should probably move to a bio paradigm in robotics as a research topic. So it's at least something that we should think about. So because the DARPA challenge is very, very, very expressive. No? But now, just to, because people working, for example, in prosthetics are on the border, because if you want to add a robotics hand to my arm here, you need to do something very similar to when you connect a printer, right? You needed to connect the wires of your robotics hand to the arm. But exactly like with a printer or a robot connected to a computer, you needed to know which kind of signal is going up and down in the wires. And this is force you to force you to understand how biological systems work. And so to make and you see that there are this story of the high bandwidth brain-computer interface. A lot of people are working on it. DARPA is asking ideas on that. And so increasingly, there is a part of roboticists which tend to think of robotics as a science. And here comes some issue, because typically, if those of you, or when you will check robotics publications, you will see that they are very similar to this concept. Now, I show you that I did something fantastic. Something great. I have a robot doing very strange things without any help. Maybe, but as I was saying before, even you may know this is a parodistic Boston Dynamics, not Boston Dynamics video. But if you check on YouTube, you may have the impression that robots can do everything. That's not completely true, because if you ask Mark Rybert, as they did, Wired did in December last year. Well, this happens 5 times of the times. So 1 times every 20. So we are still a bit away from doing the kind of things that you think about robot when you watch science fiction movies. So we can do what I was telling you before. So we can really have a huge impact on the economy, including having reusable rockets. But these kind of things in this kind of videos are still a bit in the future. Now, and the underlying issue here is the fact that typically in robotics, we don't allow to reproduce work. So there is this tradition, which is to write a journal paper where you describe what you were able to do. But typically, you don't allow what is the basis of a scientist. So we pretend to be scientists now, no? The scientist, how intelligent behavior can be engineered in a machine. But then our methodology, research methodology and publishing practice is still not so scientific, because the basic of science is that you claim something, and then I can check if what you claim is true. This almost never happens in robotics. And so in particular, the IEEE Robotics and Automation magazine is the first journal in history to allow the publication of reproducible articles, which means that you have the equivalent of a past of a journal paper, but also you give me the data sets. You clearly tell me which code, which software you have used, and you clearly tell me which hardware I should use to get your results. This is reproducibility is now an IEEE research. I don't priority. Another interesting thing is that you have seen what's happening in the DARPA, that challenge, that most of the times robots don't work. But this is in part a consequence of the fact that when we publish our research results in robotics, we don't give the statistics. But if I don't give you the statistics, we cannot improve the statistics. So even the p-value that some of you, for sure the professor know, is very criticized in biology, in medicine, in psychology, because it's not good enough to say if you have proven or not something. But this is very rarely used in robotics, usually only by people working in human-robot interfaces or rehabilitation robotics. On the other side, you see how many different ways are there to organize a statistical study. So in a sense, robotics is just coming of age. So despite being very developed, despite being very still, the fact that still we could do a lot of things in the everyday life that is already allowed, but what we know, still from a point of view of science, we are in a coming out of adolescence. Now, for reason, no? So we are far away from you propose an equation and I check the period is that following coming from the equation. So this is an interesting topic by itself. But in essence, the idea is that we are just starting to publish a reproducible article in robotics. And many people, including me, think that this is something that we need to do if we want 10 years from now be able to have much better performances in a challenge like the DARPA robotics challenges. Because also the issue that I was raising before, no? That some think that we have, if we wanted to advance beyond where we are now, we should follow the biological example, draw inspiration from the real way that life is organized. Well, it's a nice intuition, a nice idea, but how we can check if it is correct? If it is not just enough to add more microprocessor to the robots of a DARPA challenge. How we know it? We need to perform experiments. But if we want to perform experiments, they have to be reproducible. Otherwise, we cannot check. The same for intelligence. Actually, I'm the coordinator of these Shanghai lectures. In the Shanghai lectures, the idea is that we should look for, not for data processing, algorithmic kind of intelligence, but we should go for a different approach of emerging cognition. How we can check? Only by experiment. So to conclude, not only we are probably, so we can do much more than we have done. We can probably, the second wave can already probably save the planet, so to speak. We have issues. For example, when you have a car accident, who is guilty? The car producer, the driver? This is a problem that needs to be solved. Another aspect that I told you, I'm not very scared by this. This is a study from to Oxford, Osborne and Fry from Oxford a few years ago. So they were saying that about half of the jobs could be automated in a matter of 10 years. Okay, that was 2014. We are in 2020, so it really didn't happen yet. But I mean, how I can say if it will happen or not? Again, I needed to have objective ways to evaluate what works and what doesn't. And as told before, then there are the day that we really, I told you that I'm not very worried by the fact that we have a technology which allows to have a productivity work done per hour 10 times or even 100 times more than before, because we are facing a kind of science fiction catastrophic change in the planet. So the more we can do by technology, the better. So I don't expect a lot of unemployment. I expect a shortage of people. But then the day that we could have could be the Greek society without slaves. Is that something bad? That robots do the boring stuff and we can concentrate on science, philosophy, art, or poor entertainment? Because then we have, for example, this is a problem that we have in Europe or Japan, and tomorrow in China. What we do with all these old people and how we substitute them. As told, well, I'm not so worried. And then it is better to give prosthetics to the elder or to have to simply engineer their body to make them younger. Well, this is another. So this I finish here by advising you to check this book by, again, actually two scholars, professors, two Oxford professors, which compare the current situation of our global society to the situation of a Renaissance in Europe. You know that the peak of European civilization was probably the Renaissance in 16th century, no? Because there was a flourishing of art. Okay, if you look to that age with a historical objective eyes, you see it was a terrible age. They had plagues, they had pandemics, they had wars, religious wars, economical wars, and they had just discovered America. They were able to cope with the challenges. Probably we can too. So for the reason that I have told you before, what I think talking about societal impacts in general, we should be aware of is that it's not a simple thing. It's like the steam engine. This is going to change very deeply the way society is organized. Is that a problem? Yes. Is a problem in the sense that we need to see what we can do. But for sure, we have a lot of opportunities, and they are very welcome because we also have a lot of problems. So I finish here, and I really think that I told this before, this is really a it's a unique or very rare period in the history of technology, of a society where you really can do something new. There have been ages where people always used the same recipes to do the same thing. This is a situation where you have unlimited possibilities to invent new things and new way of doing all things, and so thank you for listening, and I'm happy to answer some questions if you have, and if it is not too late.
Thank you, Professor. Thank you very much for the informative session. Started with the birth of the robot, and we have given a complete journey of what is the current scenario of robotics with AI. And not only with the technical part, you also covered the social impact of robotics in current scenario. Thank you very much, sir. So now I request any of the participants either to ask a question or give a feedback. Thank you, Professor. So if any question or any feedback is there, I will post you, sir. So thank you once again for sharing your time and giving a wonderful lecture, sir.
Thank you, and thank you for giving me the opportunity to share some ideas. And I will be very happy to answer also offline to any question by email or whatever that you may have. The students,
we'll collect the questions from the chat box and mail you, sir.
Okay, thank you.
Okay.
There is one question. There is one question, Pungoli.
Yes, ma'am. Yes, ma'am.
How can the cost of a robot be reduced in the long run?
Long run.
Yes, this is, thank you for the question. I think that this is one of the things allowed by these changes. I didn't quote 3D printing, for example, but by having control system, for example, more sophisticated control system, for example, using machine learning for the control. Actually, I'm working on something like that. You may actually drastically reduce the cost of the robots. But you are right, this is a critical issue because Also, the usage in industry is usually based on expensive robots. Having more control and merging with humans actually allows to reduce it, but still probably not not enough. I think there are examples of this kind that by using more intelligence and better control, you can actually reduce the cost of robots. So this is one of the, it's a bit an area which is a frontier, but between the second wave and the third wave, right? But what I called the third wave. But I think that the key is using more intelligence. So it's the frontier, because it's true that it's still so it's true that in factories or for certain agricultural applications or for the circular economy, you already use a lot of money, of resources, expensive stuff. So it's not a big, for a massive adoption, I think that the key is to use, this could be another, but the key is to, I think that machine learning can use you, help you, and there are different ways to engineer robots which are really inaccurate and can perform tasks. Because, okay, I risk to give you an answer almost as long as the, but if you go back to the standard industrial robot, typically it is heavy. And it uses very accurate sensors, as you know, and very accurate, very good motors, very precise motors. And it has a control which is typically linear. To have a linear control on a structure which is inherently non-linear, you need a very heavy structure. So this is the reason why you have very expensive robots. The path to follow is to use less accurate motors, less accurate sensing, for example, PC cameras, and you use a much better control. This, so actually I'm doing some work on that, and it is one of the bottleneck. But sorry, I'm repeating myself. I think by merging machine learning with other control methods, you can compensate the inaccuracy that by necessity you having a cheap robot. It's just a skeleton answer, because we should go much deeper, but this is, I don't know if you are happy with the answer.
Yes, sir. Thank you, sir. Thank you for the patience answering, sir. So there's another question. What are to deploy robots in army?
Army, yeah.
Sorry, can you repeat?
What are the ways to deploy robots in the army?
So
In
you
military service, sir.
For
In the
military.
military service. Yes, sir. Yes, sir.
Well, I'm afraid, I mean, there are two ways to answer. One is that they, for example, if you think to drones, military drones are already in usage. No? You know that in northern Pakistan, they have been used to hit Taliban's, right? So actually, I think we should prevent the military usage of these technologies. I notice with regret that they are already in use, because what really worries me, and I think should be really banned is autonomous killer robots. Because I mean, I am of course totally against war, any kind of war, right? But then you know that sometimes war happens. But it's a very different thing if you have a robot that before killing, you have a human in the loop. So there is a human which press the switch the last time, or you have a robot that by following an algorithm kills people. Because this second thing, for reason that I think have emerged from so if you think to those robots which which fall most of the times when they operate evolve, they should recognize that I am a terrorist and kill me. I mean, that level of intelligence doesn't allow, so in principle, you should not kill people at all, right? You should not have war. But if you really wanted to have war, please don't let the robot decide by an algorithm who should be killed. So I think that killer robots, so autonomous killer robots should be, I think should be banned, and I'm not alone. I'm probably even very pleasing when I say, okay, you want to use a robot, to use it, but, right? This is probably already a militarist position, but really killer robots are a huge risk because you don't know what happened. They could come to kill you. So, I mean, you are the owner of a robot, but I mean, we are not at that.
Yes, sir. Yes, of course, sir.
Yeah.
So we have n number of application where we can use the robots in a more effective way rather than having to be so.
And also, if you use robots to improve the way of the quality of life of more people that we can, probably we will also have less reason to have wars. So because it will be difficult to convince someone happy to no. So I think we can do a lot of other things. So we have enough work without.
Yes, sir. Yes, sir. Yes, sir. So thank you very much, sir, for your patience answering the questions. Thank you very much, sir.
It was great. Thank you. And,
thank you, sir. Yes, sir.
Bye.
So I request the participants to fill the
Dear
feedback
participants,
form. Yes, ma'am. Yes, ma'am.
you continue. You continue. அதான் சொல்ல வந்தேன். Pungali, stop recording and live.
Ma'am?
Stop the recording on YouTube live.
Okay, ma'am. Okay, ma'am.